As early as in 17th century before Christ, the human on the earth used the solar system for the very first time. They used the magnifying glass to make fire. Later on, Greeks and Romans used concentrated mirrors for the same purpose. In the 18th century, Ross de Saussure built heat traps like a miniature train houses. He built hot boxes using different glasses, not more than 5. When exposed to sunlight, the temperature in the inner bottom box raised up to 108 degrees centigrade, sufficient enough to cook food and to boil water. In 1873, British engineer Wilfred Smith found that selenium's conductivity increased when exposed to light. 3 years later, in 1876, scientists William Grill Adams and Richard Hammond Day used selenium to build the first true photovoltaic cell. It produces electricity from light, no moving parts, no fuel, just sunlight. In 1883, American inventor Charles Phillips built the first solid-state solar cell using a thin layer of gold over selenium. It was only 1% efficient, but it worked. Phillips dreamed of solar panels powering homes and cities, but the world wasn't ready yet. Coal was king, electricity was new. Solar power remained a laboratory curiosity. In 1905, Albert Einstein published a groundbreaking research paper on photovoltaic effect, on how light knocks out electrons from the atom, creating current. And he received Nobel Prize in Physics in 1921 as well. At the same time, inventors and researchers were thinking, but efficiency was still too low and cost too high. The world needed better materials and a new kind of technology. Everything changed in the 1950s. In 1954, scientists at Bell Laboratories, Darrell Chapin, Kelvin Fuller, Geraldine Pearson, created the first practical silicon solar cell. Using purified silicon, they achieved an efficiency of about 6%, revolutionary at that time. The device could actually power small electronics. It was the birth of modern solar panel. Bell Labs unveiled it with a small solar-powered toy Ferris wheel. Headlines called it the beginning of a new era. But once again, solar was ahead of its time. In the late 1950s, the world entered the space age, and suddenly, solar panels had a purpose. Batteries were heavy and short-lived, but solar panels, lightweight and able to recharge continually in space. In 1958, Vanguard-1, the fourth artificial satellite ever launched, became the first to use solar power. Its tiny solar cells powered its radios, which transmitted data back to Earth for over 6 years. Soon, solar panels became standard on satellites. From the Voyager probes to the International Space Station, they have been crucial to space exploration ever since. As the cost fell, the solar panels found uses on the Earth, especially in navigation, telecommunication, oil rigs, and weather stations. In the 1970s, with the oil crisis, interest in alternative energy surged. Government-funded solar research, scientists improved efficiency and durability. By the 1980s, solar panels began appearing on homes and buildings. Still expensive, but now possible. Japan, Germany, and US led early adoption. And a new idea took shape: solar farms, large-scale installations to feed electricity into the grid. Throughout the 90s and early 2000s, the solar technology matured enough. Efficiency increased from 6% to 15%, and the cost suddenly decreased. Government started to fund the researchers and to give incentives to those who were installing solar panels. Countries like Germany launched aggressive programs to support renewable energy, fueling massive growth in solar panel installation. At the same time, off-grid solar became a game changer in the developing world, bringing power to villages without traditional infrastructure. The 2010s marked a turning point. Solar went from niche to mainstream. Between 2010 and 2020, the cost of solar panels dropped by nearly 90%. Commercial panels reach 20 to 22% efficiency. Experimental design exceeds 40% in labs. Gigantic solar farms were built across deserts, rooftops, and farmland. Companies like Tesla, First Solar, and SunPower pushed the industry forward. Solar City helped popularize solar leasing and home installation. In 2016, solar energy surpassed fossil fuels in new global capacity additions for the very first time. As solar spread, the researchers looked beyond the traditional solar panel. It is clean, it is renewable, and it's abundant. Earth receives more energy from the sun in 1 hour than humanity uses in a year. Solar energy is now a critical part of global strategies to cut carbon emissions and transition away from fossil fuels. Today, solar accounts for around 5% of global electricity, but that number is growing very fast. Nations aim for net zero goals, and solar is at the heart of many climate pledges. As the man conquered many aspects of solar energy, there are still many challenges, like we need better batteries to store electricity. Managing solar alongside traditional energy sources requires smart infrastructure. Millions of panels will reach end of life in the coming decades. Disposal and recycling will be crucial. Solar must be affordable and available in all regions, including developing countries. But innovation continues. Research into solar hydrogen, artificial photosynthesis, and space based solar power is pushing boundaries. The future of solar panels may look very different. Transparent solar cells could turn windows into power generators. Printed solar cells might be rolled out like wallpaper. Self-healing materials may extend panel lifespan. Space-based solar stations could beam energy back to Earth, and solar drones may fly perpetually, powered only by sunlight. With every improvement, the dream gets closer, a world powered cleanly, sustainably, and affordable by the star that gave us life. From a teenage scientist's discovery in 1839, powering satellites, cities, and homes, the solar panel has come a long way. Well, it is more than a technology, a symbol of our ability to learn from the nature and to build a bright future. As long as the sun shines, the development in the solar panels will remain intact for a greener and pollution-free environment. So for the more knowledge on the solar installations, the solar panels, and solar technologies, you guys need to be the part of this channel. You guys need to be the part of this family, as there is many more to come.